let's get this going here. Standard 15 in Unit 4 focuses on what's called the expected value, calculating the expected or average value of a random variable. We'll be looking at the average and standard deviation of the values of a random variable here in S15. A random variable is a variable whose values depend on a random experiment. A random variable takes on the values, any values of a random experiment. Rolling a dice is a random experiment. What are the values possible when I roll a dice? When I roll a dice, what numbers could I get?
1, 2, 3, 4, 5,
1 through 6, right? My random variable could take on any of those values 1 through 6. Drawing 3 cards from a deck is a random experiment. I want to figure out the number of hearts. If I draw 3 cards from a deck of cards, what are the different numbers of hearts that I could have in my hand? How many cards could be hearts that are in my 3-card hand? I could have 1 of the 3 cards be hearts, 2 of the 3, or all 3, right? My random variable, the number of hearts in my 3-card hand, could be any value, 1, 2, or 3. All of these different outcomes are finite experiments because it only has a certain number of values for the random variable. If I roll a dice, I can only get the numbers 1, 2, 3, 4, 5, 6. It's not an infinite amount of possibilities. It's finite. There's only certain values that my random variable can take on the value of. If I pull 3 cards from a deck, there's only a certain number of cards that can be hearts, 1, 2, or 3. Random variable is any variable that takes on the value depending on a random experiment. Some notation here in this next row. Here's notation for the probability of a random variable. P for probability. I denote the random variable with capital X. The specific outcome of that random variable, the numerical part, is lowercase x. Going back to rolling a dice. The probability that my random variable is equal to 6. What's the probability that when I roll a dice, I get 6, is what this is trying to say. Capital X is the random variable. X is any of the values that random variable could be equal to. Lowercase x is the actual values. The random variable is given by uppercase x. The formula for expected value or average value is here to the right. E of x, E of capital X, is the expected value of that random variable. It's otherwise known as the average value. Mu is notation for average. This is Greek letter mu. The expected value or average value for our random variable is the summation. This is Greek letter sigma, uppercase sigma, the summation of x times p of x. Take each outcome times the probability of that outcome for our experiment, multiply them together, and add them all up. This means summation. Take the sum, add them all together, of the product of each of the respective outcomes in the experiment times the probability of that outcome. The summation of x times p of x, the summation of x times the probability of x, should give you the expected value or average value for that random experiment. You pass this out next. We'll work with what's on here for our period together today. All right, those of you online here, grab Schoology and open up the S15 folder inside Unit 2. I'll share my screen so you can see what we're going to use here in class this morning. Unit 5, S15. It's the expected value practice PDF that I've got right here. If you click on expected value practice PDF, it's going to have what we're going to use here in class this morning. And there we go. We're going to work through these 5 examples here together. Did you find that okay?
Yeah, I found it good.
All right, sounds good. Okay, so on that handout I just passed out, has some good practice questions for us to look at together here in class as we're getting started with expected value. Let's flip up to the top. Question number 1. Consider the number of loudspeaker announcements per day at a given school. Suppose that there is a 15% chance of having no announcements, a 30% chance of having only 1 announcement, 25% for having 2, 20% for having 3, and 10% chance of having 4 announcements. What is the expected or average value of the number of announcements per day at school? Well, let's go ahead and define the random variable. Uppercase X is the random variable notation. What's our random variable here for this experiment? Announcements per day, right?
Yeah.
School announcements. Number of school announcements. This is a finite random variable. So what are the number of announcements per day? From what to what?
0 to 4.
0 to 4. So those are the specific outcomes that our random variable can take on. In other words, that's the lowercase x values. I make my distribution table, lowercase x, the specific outcomes of this random experiment that were given to us are 0, 1, 2, 3, and 4. As a result of this experiment, they had anywhere between 0 and 4 announcements at school. The next column in this table is the probability of our random variable being equal to these outcomes. The probability of the number of announcements being equal to either 0, 1, 2, 3, or 4. What's the percent chance that they had no announcements? 15%. That's going to go right here. 1 announcement, 30%. 2 announcements would be 25%. 3 and 4 is 20 and 10%. There is our distribution table, our probability distribution for this random experiment. What should all the probabilities add up to, obviously? 1 or 100%, right? Now, the expected or average value for the number of announcements is the summation of x times p of x. So what we're going to do is we're going to multiply each outcome times its respective probability, then add all those values up. So the expected value will be 0 times 0.15 plus 1 times 0.3. It's the summation of each of these paired products between the outcome and its respective probability. 2 times a quarter. 3 times 0.2. And 4 times 10%. Type that into your calculator, and you'll have the average number of announcements at school, per day at school. Does 0 times 0.15 really matter? You really need to type that in?
No.
It's nothing. It's not going to contribute. anything to our average value. So I'm going to take 0.3 plus 2 times 0.25 plus 3 times 0.2 plus 4 times 0.1. 1.8. What does that mean? What does that number tell us in context?
The average number of announcements.
On a given day of school, I'd expect about 1.8 announcements. Are there some days where I'd have more?
Mm-hmm.
Yeah, are there some days where I'd have less?
Yep.
It's random. Who knows what's going to happen? But on average, there's 1.8 announcements for any given day of school. Does that make sense?
Mm-hmm.
Okay, try number 2. Let's flip over to the back side, and I'll have you guys work on number 2 for a minute. Number 2 on the back of the first page. Suppose a coin is flipped 4 times, and let x equal the number of times that the coin is a heads. The table below gives the probabilities of the number of heads. So I get 0 heads 1/16 of the time, 1 heads in my coin 4/16 of the time, and so on. Find the expected or average number of heads when I flip a coin 4 times. I already give you the table, right? So what do I have to multiply together? I take 0 times and 1 times, and then add all of these paired products up. Answer is up on the television screen. I suppose that makes sense, doesn't it? If you flip a coin 4 times and half the time you get a heads, wouldn't half of 4 being 2 tell you the number of heads you get on average? Let's see here. 0 1/16 of the time plus 1 times 4/16 of the time plus 2 6/16 of the time, 3 1/16 of the time. Nope, 4 plus 4 times 1/16. Looks like 2 there. Flip a coin 4 times. On average, I should get 2 heads. Does that mean you're guaranteed to get 2 heads every time you flip a coin 4 times? No, it's going to be some variation, some variability. Tomorrow, we're going to talk about standard deviation, the variation from the average in a random experiment. I should get 2 with this amount of variability. That's what tomorrow's focus is. Anyway, let's start with number 3 then. These next couple ones talk about games of chance. A very nice use for expected value is to determine if a game scenario is favorable to the player or to the house. Who's got the advantage in a fair game? A fair game is one where there's no advantage for either the house or the player. No one's got a leg up. There is no advantage for the house who's running the game or the player if the game is totally fair. In other words, in a fair game, the expected value or average outcome should be 0. If the expected value is negative, who's got the advantage? The player or the house? The house, because by playing the game, aren't you expected to lose money if your expected value is negative? If the expected value is negative, by playing the game, on average, you're going to be losing money. What if the expected value is positive? Who's got the advantage now, the house or the player? Player, because by playing the game, aren't you expected to win more money than you lose? Yeah. In a fair game, the average outcome would be 0 because nobody's winning or losing any money. So let's see if this game scenario on number 3 is favorable or unfavorable, or a fair game, by calculating the expected value. Still in frame. All right, so suppose there's a game where the player rolls a die and either wins or loses money according to the given rules. If they roll a 1, 2, or 3, they'll lose $5. By rolling a 4 or 5, they'll win $1. And should they roll a 6, they'll hit the jackpot and win $10. Let X be the amount of money that a player wins or loses in this game. That's our random variable. The different values of X that random variable could take on would be -5, 1, or 10. Why is 5 negative? Losing $5 by rolling a 1, 2, or 3. So I'll have X for the first column. And the probability that X equals X, uppercase X equals lowercase x in the second column. They've already given you the outcomes of the game. -5, 1, or 10. I could lose $5 or win 1 or $10. What's the probability I lose $5? 1/2. 3 of the 6 rolls, 1/2 of the rolls would lose you $5, rolling a 1, 2, or 3. What's the probability I win $1? A third, 2 of the 6 rolls. And I win the jackpot of $10 by rolling a 6. That happens 1 out of 6 times. Well, let's get the expected value. On average, how much money should you win or lose by playing this game? That would be -5 times 1/2 plus 1 times a third plus 10 times 1/6. I take each outcome of the random variable times their suspected probability and then add them all together using that formula in your notes. What do you get? -50 cents?
Yep.
So on average, by playing this game, you're expected to lose 50 cents every time you play. That doesn't mean it's going to happen every single time, but in the long run, on average, you're going to lose more than you win. Approximately 50 cents every time you play the game, you will lose. So who's got the advantage? Obviously, this is an unfair game. In terms of the player, is it favorable or unfavorable? Unfavorable, right? Because it's a losing proposition. It's a losing bet. Right? Most casino games are unfavorable for the player, right? Because Las Vegas wasn't built out of the house's money. It's built from the player's money, right? Las Vegas just didn't come out of nowhere. All casino games are usually unfavorable from the player's vantage point. On the next page, let's flip over to page 2. Here's another lottery example. A state runs a lottery called Pick 6, where a player buys a lottery ticket showing 6 of the numbers ranging from 1 through 40. Then a set of 6 winning numbers is chosen, and anyone whose ticket matches those numbers will win the grand prize. The order of the numbers does not matter. So is this either a permutation or combination? Or order is not important. Is it permutation or combination? Combination. In a combination, the order doesn't matter. As long as I have that set in any order, it doesn't matter. As long as I have the 6 winning numbers on my lottery ticket, they can be any order I want because order doesn't matter. So it's a combination. What is the chance that we'll pick the winning numbers? Well, how many winning combinations are there? 3. How many winning combinations are there? How many ways are there to win? 1. You have to pick that 1 winning combination. How many ways are there to select the 6 numbers from the 40? How many lottery combinations are out there? 40 choose 6. So 1 out of 42.6 is the chance of hitting the jackpot. If I grab my calculator here, what is 42.6?
20,000 or something.
Much higher than that, about 3.8 million. So you have a 1 out of 3,838,000 and 380 chance of winning this pick 6 lottery. Okay. Now on part B, you don't win, then you lose. So what's the odds or what's the probability that I would have lost this lottery?
49 or 39 out of 40.
3,838,370.
If there's one winning combination, aren't all the other combinations losers?
Yeah.
So 3,838, 379 out of 3,838, 340. If I win with one outcome, I lose with all the rest, right? So if there's one winner, that means all the other outcomes, 3,838,379 of them, I would have lost with. Okay. What's the expected value for this lottery game? Suppose that a lottery ticket costs $1 and the price for having that winning ticket is $1 million. What is the random variable? Let's define X first. Capital X represents what? What happens when you play the lottery? You either
Win
or
lose.
okay, so how much money do I lose if I lose? How much money do I win if I win? So the random variable is the money either won or lost. If you win $999,000. $999,999. Why not $1 million? So this is my net winnings, right? Cost $1 to play. I won the $1 million. So now I'm up $999,999. What's my net winnings if I lost? Negative $1, right? So I would have lost that $1. Here's the outcome. Here's the money won if you win. Here's the other outcome, the money lost if you lose. The other column is the probability of these random variables, of these random outcomes for the lottery. I win with this probability. I lose with the other. Find the expected value for this lottery game. Every time you play the lottery, what's the average outcome? What should you expect to happen? Let's take $999,999 times the jackpot probability plus -1 times the losing probability. That's a lot of numbers to type in, but there we go. I multiply the outcome times the probability, and I add them together. The summation of x times p of x. Nope, I mixed these around. Okay, up on the television screen should be the expected or average value for this lottery game. About negative 0.74, negative 74 cents. Is that right or not? Yeah? Okay. I didn't quite type it in right the first time. So
Since the
the expected value is about negative 0.74. What does that mean in context? Sure, why?
that on average, like, you'll lose
74 cents every time you play the lottery, right? On average, you're going to lose 74 cents every time you buy a lottery ticket. Sometimes you win, sometimes you lose, but you're probably going to lose more than you win. Questions so far, guys? Okay, let's go back to the last question for number 5. I'll let you guys try this one. A litter is a set of puppies born from the same mother at the same time. Suppose that a dog breeder keeps track of the sizes of each litter and records the data. In the first column is the number of puppies. In the second column is how many litters had that many number of puppies. How many litters had 2 puppies? How many litters had 5 puppies? How many litters had 10 puppies? All right, you got it. You've got A, B, and C, and D to answer. I'll put the answers up in a minute. They give you the distribution table. What is the most occurring number of puppies for a given litter? What number of puppies occurred most often? What's the chance that a litter will have 10 or more puppies? What's the chance that a litter will have fewer than 4 puppies, pardon me? And what is the expected number of puppies in a given litter? My 2 online here, those of you guys following along, we're just working on the last part, number 5, on that PDF expected value practice that you pulled up on Schoology. If you're following along with us. We'll go over it in just a couple minutes.
What? I have class. I go to class. No, we don't go to class. We go to class. Obviously.
How many litters were there for this dog breeder? Talking about probability, I have to know the total number of litters.
40.
40, right? Yeah. Just add up that entire right-handed column. How many litters were there in total? 40.
How would you find that?
We have to take the number of puppies times the number of litters. So take 1 times 1, 2 times 3, 3 times 3, and so on. And add them all up and divide by.
Oh, you divide
I mean, one way to do it would be like 1 times 1/40th plus 2 times 340.
Yeah.
Plus 3 times 340.
That's
But
what I take for them.
rather than type in dividing by 40 11 times, can't you just divide by 40 at the very end?
That's probably smart.
I think so. So I'm gonna check your work.
It's only some 200 something. I'll see right.
I've got this as our answer key for number 5.
7 times 6 is 42.
Isn't 7 the most occurring number of puppies that happens in
Almost.
You're actually working on part D right now, which is fine. We're just doing this one first. You're finding the average number of puppies per litter. You're taking 1 times 1 and 2 times 3 and 3 times 3. We'll figure this out and divide everything by.
What's this do?
Two weeks tomorrow. So Tuesday before Christmas, December 27th. We might finish up a couple of days, depending on how long it takes to get through this next thing.
What does he want?
I'm also going to be going next
You got
week.
him out? Gotta remember what those two. Oh.
I'm working practice stuff with you for you with this.
How's that not?
You going?
You're a player.
Be a video or two. Watch it.
Yeah, it's just like Ethan recycle. Oh, no. I'm not problems don't recycle.
Fine.
Never use
That was my favorite time for the 19.
All right. Looking on some of your answers here, guys, let's go over these. What is the number of puppies that occurred most often for the dog breeder? 7 in a litter, right? And that happened how many times? 9 out of 40 is the chance. What is the probability of having 10 or more puppies in a litter? So that means you could have either 10 or 11. That's 3 out of 40. I had 10 puppies in 2 litters. I had 11 puppies in 1 litter. So altogether, that's 3 out of 40. What's the chance of having fewer than 4 puppies? Meaning you could have either 1, 2, or 3. 7 out of 40. Now, on the last one, part D, I want to find the expected number of puppies in a given litter. What is the average number of puppies per litter? So let's take 1 times 1, 2 times 3, and 3 times 3. Take the number of puppies in each of these litters times the number of times I had the puppies in those litters. 4 times 4 and 5 times 5. And then what else? 6, 7, 7, 9. Now I've got 8, 5. I'm not going to include 9, 0. 10, 2, and 11, 1. Awesome. All right, so that would be the number of puppies times how many litters had that number of puppies. What number is that when I multiply and add all those together? 200 and
23.
I think it's 233. Then I divide by what? 40. To get the average number of puppies per litter. So 233 divided by 40 is about 5.825. So if X represents the number of puppies in a given litter, the expected number of puppies per litter is about 5.825 puppies. Sometimes more, sometimes less, but on the average, there you go, about 5.825.
Little weed. It's a packet. Oh, we literally